So you want to perform a particular cross. Dihybrid cross. And you want to cross two different things. A Mendelian cross, for example, where garden peas is looked at, and you look at garden peas, and you want to cross a specific genotype, specific set of alleles, with another set of alleles. This is homozygous dominant for yellow, homozygous dominant for round, homozygous recessive for green, homozygous recessive for wrinkled. So, crossing these two together, every single possible combination, crossing this Y with this Y, would give me, crossing this Y with this Y will also give me the same heterozygous dominant. Crossing this Y with this Y will give me that same heterozygous dominant. Crossing that Y with this Y will also give me that same heterozygous dominant. So, another combination, well, this would be this yellow, crossing this yellow with this round, this R here with this allele will give me this combination. Every other set that I do will give me the exact same combination. So all my F1s, or my first allele generations, will give me this cross. Using this same cross, if I was to allow this to self-fertilize, that means it's being crossed with itself. What I would do is allow to cross with itself. If I allow this to cross with itself, then I have to do combinations of this allele with that allele. So I'll get this allele with this allele, I'll get that. And this allele with this allele, you could get this one. And this allele with that allele, you'll get this. So these are four different possibilities. Note that this is heterozygous dominant for the yellow. This is also heterozygous dominant for yellow. These alleles, they're interchangeable. This is exactly the same thing. So to get possible combinations for my R, or my round and wrinkled, crossing this R with that R, I'll get this. This R with this R, I'll get that. And this R with that R. And this one with that one, homozygous recessive. So if you notice, you could get possible combinations for this, that, this, or that, right? So these are all the combinations that you could possibly get for this homozygous dominant here. Get all that with all of these combinations here. Same thing with this with all of these combinations, and same thing with that with all of these combinations, and same thing with this with all of these combinations. Together, there will be 16 possible combinations. And we could write all these combinations out right here. This is one set. You do the same thing for the others. That's the second set. The third set would be this one, this combination. Let's just write this all the way down. And then this is one set, two sets, three sets, and the fourth set would be homozygous recessive. Oh, this will be actually capital R's. So these are all 16 that you could all 16 possible combinations that you could have when you do the crosses. This is one way of doing a dihybrid cross.